Hello, my name is Vishal and I am from ARTC. We are presenting on achieving sustainable HVAC operations. This is part of a multiple suite of platform what we call REMAP. And this solution mainly targets towards energy and climate management for sustainable operations. Our end goal with this is very simple, to target at mainly facility equipment. The idea is very simple. We want to improve the energy of HVAC systems for climate control of target spaces. We also want to minimize energy consumption through data-driven optimization and control logic. Space requirement fulfillment is very important for varying use cases such as industrial environments, office environments, and even clean rooms. Based on dynamic loading, and therefore we want to provide ambient external conditions as a key problem. We also want to provide a consolidated dashboard for monitoring of energy consumption and sustainability with the idea of one-click reporting. How does it work? The idea is very simple. We take our three main focus areas: the data layer, the control layer, and the platform layer. It basically has three main components on the data layer, the climate management side. This is where we have the airflow sensors, temperature, humidity, and so on, which comprise of the climate control. Then, with this information usually obtained from a building management system or from external sensors, these are the key information we want to capture: temperature, humidity, airspeed, and external outdoor weather. We also have industry-specific operations. This is what we call our unique edge, because we want to capture industry information that allows us to merge with the energy and climate information together. So now this can be consistent of office, which can be occupancy, production, which is machine load, and clean room, for example, if it's a particle count sensor. We want to merge this information with the climate information and see what are the correlations we can find. Then we look into the facility equipment. This is where capturing the energy data is the most important. Because again, not to forget, our end goal is to optimize our energy consumption and make sure we maintain the climate requirements. All that information gets funneled into our own database, our own platform, and based on our key correlation matrix and our optimization engine, we are producing good key information results that we can see on an easy-to-use dashboard for easy viewing. We have done the experiments on this and we see validation and feedback from the industry. And this is one of the existing cases that we have applied our use case to. We have our current situation room that is currently being filmed right now. It's basically a zone 1 and zone 2 that you're currently viewing as of this moment. The current zone 1 is basically the room you're currently looking at, and the room behind this projector is one of the other called zone 2. So these are what are the constraints that have been set for this room. We have defined it as human defined for this particular room, and the room behind has to maintain 22 degrees in order for the projector's operations. It's a high energy device which consumes and produces a lot of thermal load. We capture this key information based on this. We try to identify what is the temperature and the projector temperatures, and we capture this information. We then calculated what's called PMV, or thermal comfort. The idea is how can we optimize it for thermal comfort for this room because of other external factors that can affect it. This is how the thermal comfort model was derived. It consists of environmental factors along with human factors, which is shown right over here. And it has a scale based on this from +3 to -3. We then want to basically move our current temperature data to a more optimized control. And this is what the magic of ECMAS does. It tries to provide you an optimized temperature set point that is dynamically adjusting to what the requirements are. And this variation in energy can actually be very useful. The set points that provides or recommends can help you improve energy from the current set point to the optimized control. And with this objective, we are able to reduce the HVAC costs by right-sizing the HVAC. That's the end goal of this. We want to right-size the HVAC for energy consumption and what the climate requirements are for the room. And we want to replace or augment human decision with data-driven decision making. That's the end, also one of the things we're considering. And most important thing is, for this use case that we've identified, we want to do holistic consideration of thermal comfort for occupant well-being. We have applied this as a validation test in industry, and now we have current projects that are working towards more industrial use environments where we applied for temperature control, humidity control, and clean room control. And with that, I end my presentation.